In this session, we will be learning different kind of programs related to conditional statements, iterative statements, and functions. The first program is to find whether a number is even or odd using if-else. The main method, and inside the main method, we are declaring a variable a, and this is the input function where you need to enter a number and that number will be scanned into variable a. So to check a number is even or odd, let us take one case. If you want to check whether a number is even, that number must be divisible by 2. I can say that if the number which is divisible by 2 will have a remainder 0. So if that number divisible by 2 remainder is 0, then I can say that the number is even. Nothing but if I take any random number and modulo of 2 gives me 0 when that number is multiples of 2. Nothing but when that number is even number. When a is even, then a modulo 2 will be 0 because a is multiple or divisible by 2. Okay, so if this condition is true, then I can say that a is even, and in else case I am saying a is odd. Simple. So the logic which you need to identify here is even. Take any one condition. For even, I can say that if a number is divisible by 2, I can say even. So a, let us take any number a, and if a mod 2 is 0, nothing but when you will get remainder 0 when that number is divisible by this number, this 2. So if a is divisible by 2, then we will get remainder as 0. Nothing but a are multiples of 2. In the sense, a is a even number. So that's why I'm saying a is even. And in else case, we are saying a is odd. Let us execute this code. Enter a number. I'm telling 8. A is even. Let us execute it once again. If I say 57. 57 is even? No. 57 mod 2. 57 mod 2 is 1. But if it is 0, a is even. So else case, that is a is odd will get printed. This is about if else case, and next let us look into ladder if else. Ladder if else, we are taking 3 numbers to find the maximum among those 3. Let us say the numbers to be a, b, c and integers. Okay, a, b, c are integers. This is the input statement where you need to enter those 3 numbers, and those 3 numbers will be scanned into a, b, c into their addresses. Okay, now I'm saying that if a is greater than b, logical and a greater than c. Nothing but what? From this both you can say that a is the greatest number. So I'm printing a is greater. So you want to print greatest among these 3. You can say that a greater than b and a greater than c. So this implies a is greater than b and c. Nothing but a is the greatest. So that is what I am printing here. And in else case, I am this is an if else if ladder. Okay, ladder if else. In else if case, I am using next variable, that is b. I am telling if b greater than c. So if b greater than c, I can say that b is greater. Nothing but that percentile, that number is greater. Here also same percentile, that number is greater. And in else case, nothing but a is not greater and b is also not greater. I can say c is greater. Nothing but that percentile, that value is greater. Okay, let us execute this. If I take 80 and 100 and 50, 40, let us take 17. 100 is greater. Okay, so how this got implied? Let us take this to be 17. 80, 117 are A, B, C. Okay. A greater than B. Nothing but 80 greater than 100. Is 80 greater than 100? Yes. Is it? No. 80 is not greater than 100. A greater than C. Is 80 greater than 17? Yes. So this is true and this is false. So from these both, we will get false. So this if condition will not execute because it is logical and both must be true. Both conditions must be true. And B greater than C. 100 greater than 17. Is it true? Yes, it's true. So you got the answer B is greater. No need to do this else. It will return 0. Okay. That is the case. A simple case which I have taken. Let us take another 1080. 1000 is greater. Okay. In that way you can find the greatest among 3. This is the nested if else. Same, finding the maximum among those 3. Nested if else in the sense if inside a if. Okay. Taking the inputs ABC input statement where you are scanning those values into ABC, addresses of ABC, address slots. Okay. First I'm writing if A greater than B. If A is greater than B, see, if A greater than B, then I'm writing again if A greater than B, A greater than C, sorry. Then you can say that from this A is the greatest. A is the greatest. A greater than B and A greater than C. If these both are true. And in this if A greater than C, in this if I'm writing an else. Okay, you can check here. In this if I'm writing an else. So A is greater than B is true, but A greater than C is false. That means C might be big number. That's why I'm saying C is greater. C is greater. And if A greater than B is completed, so another condition will be what? B and C, between B and C. A and B is completed, one case, if case. And else case, that is between B and C. It will be between B and C. Here we need not specify any condition. This is a false condition. So I am writing inside this if B greater than C. Here we have proved only A and C are greater, right? Like we have given only 2 conditions related to A and C. Here we are saying if B greater than C, print B is greater. Else, obviously C will be greater. This is if else statement inside the else block. Okay, so we have written if statement inside that we have given if else, and inside else also we have given if else. Okay, this is a nested if else. Finding the largest among 3. Let us execute it. 1523, 456. C is greater. C is greater. Let us check it. Okay, it's better if you check. These are A, B and C. A, B and C. A greater than B. 1000 greater than 523. Yes, it is true. So it enters into this another if condition, nested if condition. Okay, 1000 greater than 4560. Is it correct? A greater than C. 1000 greater than 4560. No. So this if block will not execute. Immediate else block will execute. Nothing but C is greater. That is 4560 is greater. That is on your output. There is no need to execute this else block. Okay. Because the answer might lie in between these both. If this condition is true, answer might lie between these both. If this is not true, then answer might lie in this else block. Nothing but in between these both. This is about nested if else. Let us look into leap year program to find whether a year is leap year or not. So how you will say whether a year is leap or not? Remember, if it is not only divisible by 4, you might know, many people might know that if it is divisible by 4, then we say that as a leap year. No, it has 2 more conditions. it must be multiples of 400, nothing but divisible by 400. Or reminder, when divided with 400 must be 0. Okay, and it must not be divisible by 100. If it is divisible by 100, then you will say not a leap year. Okay, so once again, divisible by 4, multiple or divisible by 400s, and divisible by, not divisible by 100. Then you can say it has a leap year. So I can say simply that a leap year must be divisible by 4, and it can be a century, nothing but it can be hundreds when it is divisible by 400. Okay, that is the main case of leap year. So taking the input, checking for it is divisible by 400 or not, if, and this is separate condition, and logical or operator where we have group or a couple of condition for divisibility of 4 and divisibility not divisible by 100, not equal to. Okay, if this condition is true, and if any one of them, this one or this one, any one of them is true, then it will become a leap year. Okay, it does not depend on this only, it also depends on these both, this and this condition. We have used a or operator and saying to be leap year, and if both of these conditions are false, you will, the else block will execute, that is it is not a leap year. Let us take example, compile and run. 2000 is a leap year, divisible by 400, divisible by 4. So here you got true, in the sense it is a leap year, that's it. Let us take not divisible by 400 any number, right? Because if you get here true, now obviously that will become a leap year. Let us take 2524, not 2524, 2520. So it is a leap year. Why? This condition is true. Okay, that is about a leap year, not a leap year. Let us check into switch case vowel. So what is switch case? Switch to a particular character or an expression, apply multiple cases, and specify a default case. This is about switch. Okay, our task is to find whether a character is a vowel or consonant. Okay, so defining a character data using character data type char ch. Okay, and I'm user prompt to enter a character, scanning that into ch. Okay, switch to that character, nothing but this implies that keeping in mind about character ch, try different cases. Okay, try different cases. So to say that it is a vowel or not, you can write vowel cases a, e, I, o, u. Okay, 5 vowel cases. For all of them, we are writing a common printf statement vowel, or you can say it is a vowel. And break. Remember why we use this break statement. Okay, very important. Why we used here break statement. So if it is a vowel, then obviously it must not print this default statement consonant. You need to, this control must come out of this block. This default statement must not execute. So I am using a break statement. What is the use of break statement? It moves the control out of your block. Basically we use in iterations. Okay, out of iteration or out of block. So here I have used break so that the control will move now to this printf after switch case. Okay, so let us execute this. I'm writing some u. It is a vowel, so this default case is not printed. So you can see after switch case. Let us do some property here. If I have kept this in comment line and I'm executing it, let us say I have written A. So you can see it is a vowel, and default will print. Okay, this default is being printed again. Nothing but there is no breaking statement between these both, then both will be printed simultaneously. Default statement is the name itself indicates that default, print it by default. Whether cases are true or cases are false, default will be printed. So you need to stop to print that default. So you can use this break statement to stop printing that default. Okay, let us take the same A. You will be getting it is a vowel after switch case. And let us check for consonant as well, right? Let us say some L consonant. So case A, L is not there, here L is not there, here not there, here not there. So this is not going to print. Break also not going to execute. So the default, that is consonant, is being printed here. Okay, the consonant is being printed here. That is about vowels. Switch case, switch and break. Okay, switch, default, break. Let us look into go to label. Here we are checking for a number even or not using go to label. I have given a number or a variable I specified or initialized to 9. To check whether a number is even or not, as we know that if it is divisible by 2, nothing but the remainder is 0, then you can say it has a even number. So I'm writing instead of printf, I'm writing here go to even. So remember, go to case name. This indicates that go to case name. You explicitly somewhere in the program you must mention that case. If you have written go to case even or go to even, there must be even somewhere. Even case must be somewhere in your program. So here you can see even case, which has a printf statement and a return statement. So if this condition satisfies, then even number and return will be printed, not written. What is the use of this return is, if we don't write here return, then this odd case and this odd case will also get printed. Okay, return in the sense the control must terminate. Control must terminate or stop. That is, it must not go to next statement. Okay, that is the use of this return. And I have specified here 9, so output will be what? Go to even will be our case, and or inside or you have odd number, and the printf is end of program. Let us execute it. Odd number, end of program is output. Yeah, got it. And specify, right? Let us take 18. Control this. Running it. Even number. So even number is being printed. This is about go to label. Let us look into break and continue. What is break? What is continue? Just now we have discussed break is nothing but to move the control out of that loop or iteration or block. What is continue? Continue is nothing but in the name itself, continue, nothing but the control must not move out of that block. The control must not execute the next statement or the corresponding statement. It must iterate, it must repeat, or it must go to its before statement, but the next statement must not execute. So you can check it clearly. This is a main function. Okay, int I equal to 1. This is initialization. I have used a while loop. Okay, you can check from here the loop statements comes while I less than or equal to 10. First one is there, right? 1 less than or equal to 10 is true. So immediately I plus plus. I was turned to 2. If I is equal to 4, is it true? No. so continue will not be printed, but this printf, this whatever one is there will get printed. So 1. For that, increment, it has incremented to 2. 2 less than or equal to 10, yes, true. I equal to 2, no, so continue will not execute, so 2 will be also again printed. Okay, so similarly incremented to 3, what happens? 3 will also again printed. Incremented to 4, so if I is equal to 4, continue, so what happens? The corresponding statement, nothing but this printf statement will not execute, it will increment the incremented part, it will come again to this while loop, nothing but 5 less than 10, so if I is equal to 4, so this printf, so now instead of 4, 5 is printed. 4 is not printed because if I is equal to 4, we have specified as continue, nothing but the corresponding statement must not execute, it must go to the next iteration, nothing but 5th iteration. 4 is not printed, so it must go to 5th iteration. Similarly 6, 7, 8, 9, 10 will be printed, that is executed. You can check 2, 3, 4, 5, 6. So 4 is not been printed. Let us check into the while, simple while example. Sum of natural numbers up to n. So you need to specify a number n. Till that number n, it must find out the sum. Okay, so simple. What is the thing which you need to know? Till what number you specify, that is number n, and till where, from where you want to start. I want to start from I is equal to 1. Okay, and also I need to find sum of natural numbers, so I'll take sum. So 3 variables. Before the giving the question, you need to write like this and take the input. For what you need to take the input? How? Enter any number. Okay, enter any number. For that number I'm taking input and I have initialized. Sum is initially 0. This is the most important point, because if you will not initialize sum to 0, then random sum will be printed, nothing but sum has its own ASCII value, so with that ASCII value the sum will get added up. So you need to specify that sum is initially 0. Suppose if you take multiplication, or you can say product, right? For product you must take 1. Okay, because 1, if you multiply anything with 1, you will be getting that number itself, right? So remember this is very important while printing the sum. So I'm checking using while case, while I less than or equal to n, nothing but an iterating variable I till that n, till that number whatever you have given, till that number you increment your sum with I. Nothing but, suppose let us take an example. If my number is 5, okay, this is what, this is n, so I was initially 1, right? So 1 less than or equal to 5. So in that way increment 2 less than or equal to 5, in that way 3 less than or equal to 5 till 5 less than or equal to 5. So increment option is there here, that's why I am incrementing it. So for this each case, sum must be added up with what? With incremented number. Nothing but incremented number is nothing but for each number you are checking, right? Till 5, in the sense before whatever the numbers are there, we are checking for those all numbers using that iterating variable. So simply you can add I to the sum. So what this I contains? I contains numbers less than or equal to given n, or you can say 5, given n or 5. So the same part here is been executed. and till that part you need to increment the sum with I, and after that printing the sum of natural numbers. This percentile, that's why I've kept it is an integer, right? So you need to print, and after that return statement. Let us execute this. Suppose I want till 5. What are the sum of first 5 natural numbers? You got 15. Nothing but for 1, for 2, and for 1 sum equal to sum plus 1, sum equal to 1 plus 2. So now sum will become 1, right? After this sum will become 1. For that one add 2. Now 3. 3 plus 3, 6. And for that 6 add 4. 10. And for that 10 add 5. In that way. Okay. So this is the sum of natural numbers, n natural numbers. Let us look into for loop. Okay, same program using for loop. So the only difference is here we have given only this condition, right? This updation also we are giving inside the for loop. That is the main agenda. Okay, we are giving that also. You can check I equal to 1, as well as we are giving I plus plus. So this is the use of for loop. Instead of specifying it outside the program, inside the for loop only you can give all the conditions for I1, I less than or equal to n, and I plus plus. Okay, for this you need to calculate or increment the sum with I. So sum is initially 0, and finally print the sum of n natural number. Let us take the same example 5. You got 15. Let us take some 10, right? 10 is 55 in that way. Okay, the same story comes here for I1, right? Sum equals sum plus 1. Sum is 0, right? So after this, before executing this I equal to 1, it checks for this, and also it increments it. Okay, it also increments it after this statement. Okay, after this statement, this increment will happen. Okay, remember, after executing these both conditions, this block will execute. After execution of this block, the increment will happen. That is the most important point to know about for loop. Now to print 1 to n using do while loop. So do writing some conditions. Okay, printf and increment, and while loop similarly I less than or equal to n till I less than or equal to n. Okay, let us, so here I'm not printing any sum. I want to print only the numbers from 1 to n. Okay, let us execute it. I want 10. 1 2 3 4 5 6 7 8 9 10. So if you write n equal to 10, what happens? N equal to 10. So first what happens? I is 1, right? 1 will be printed. After that incrementation, I is converted into 2, checking for the 2 and going into 2. So 1 2 to the 3 in the same way till 10 it will be printed, because here condition is equal to, right, till 10. In that way the numbers will be printed, and finally the after loop will print. This is about do while statement, a do while for loop. Let us look into examples, few examples related to the iterations. Factorial, how to find a factorial of a number. As you all know that 1 factorial is 1, 2 factorial is 2 into 1, nothing but 2. Similarly 3 factorial is 3 into 2 into 1, which is 6. So similarly the factorial goes on. So factorial of a number n is nothing but number n into n minus 1 possible ways. Okay, n into n minus 1 into n minus 2. So till 0 comes, you need to multiply it. Nothing but 0 comes, that must be neglected. Suppose 2, n 2, n minus 1, 2 minus 1, it is 1. That's it. It will print 2 in that way. So how we will write a code to it? Simple. Taking a number, taking an iterative variable because you are using iteration, taking an iterative variable, and to find factorial, taking a variable called fact. Enter any number and scan it into the variable n. I is initialized to 1 and factorial is initialized to 1. Just now I said if it is sum, initialize it to 0, or if it is product, as you know that in factorial we will be doing product, initialize it to 1. Okay, using a while condition, while I less than or equal to n, nothing but for 1 less than or equal to n, similarly for 2 increments. Okay, for each time you need to multiply your fact with the iterating variable. Iterating variable changes every time. If you multiply with 1, fact will be 1. 1 star again 2. Now fact will be 2. 2 star again 3. In that way. Okay, I will be incremented and fact will be reassigned every time. Remember, fact also will reassign every time. Fact will not be 1 every time. And finally the factorial of a number will be printed. Let us execute. If I write 8, the factorial has been printed. Let us take some small number. If I want 4, 4 is 24. So how it will execute 4? We have given 4, 1 less than 4 equal to 4, true. So fact equal to 1 star 1, so 1. Now I is incremented to 2. So 1 star 2. Now it is 2. I incremented to 3. Now 2 star 3. It's 6. Fact is 6 and I is incremented to 4. So 6 star 4. It is 24. I is incremented to 5. When it comes to 5, here you will get 5 less than or equal to 4. Is it true? No, it is false. So 24 is been stored in the fact and that value is been printed here. Okay, that is about factorial. Now let us look into Fibonacci series. Generally many of you don't know about Fibonacci series. It is very simple. Fibonacci series is nothing but first number will be 1, second number will be the sum of before two numbers. First number is by default, or you can say first number is 0, second number is 1, next number will be summation of before two numbers. The before two numbers are 1 and 0, so it will be 1. Next number will be summation of before two numbers, 1 and 1, so it will be 2. Next number will be summation of before two numbers, 1 and 2, so it is 3. Next number will be summation of before two numbers, 3 and 2. 5. Next number will be sum of before two numbers, 5 and 3. That is 8. So in this way the Fibonacci series will be going on. You need to print this. So how we will print this? Simple. I am using 3 variables. One is a variable and this variable is how it is found using the before two variables. So 3 variables A, B, C, let us assume, and the number till which number you want, till 8 you want or till 21 you want. Okay, specifying till which number you want or specifying the number of terms you want, and I, it is a iterative variable. So the scanf statement, enter how many terms you want. Okay, scanning it into n. Remember A and B are initialized to 1, so these are A and B. Let us not consider 0 here. This is A and this is B. This is A and this is B. So what will be C? Obviously A plus B. So I am starting my iteration from 2 now. Starting iteration from 2. Before that, printing the first two values A and B. Okay, that is 1 and 1. Okay, printing A and B, that is 1 and 1. After that, I am changing my I am assigning my I value to 2. Okay, from second term I want. Okay, so while loop giving a condition that I less than n, nothing but 2 less than whatever the number of terms you give. Okay, number of terms. First step is you need to find C, nothing but addition of before two numbers are a and b. So c is equal to a plus b. So you print that c immediately after addition. Okay, after addition of these two, print that c, and after this your main task is to changing the a and b, pointing of a and b. A was pointing initially here, b was pointing initially here, c was pointing initially here. After finding this two, your a must be what? This must be your a. Sorry. After this two, this must be your a and this must be your b, and this will be your c. So what's happening here? Simple. A equal to b. A equal to b. First step is a equal to b. Nothing much. Instead of b, whatever you have, there you will get a. So here a. B equal to c. Nothing but instead of c, you will be getting b. That's it. Instead of initially b was here, c was here, right? At second position there was b. At third position there was c. So now this position must be a. Nothing but a equal to b. This position must be b. Nothing but b equal to c. That's it. Or if you want, I can understand. I can make you this way. Initially, this was a, this was b, and this was c. Now, what must be my a? This must be my a, and this must be my b. Nothing but what I can write from this. Assign b to a. Nothing but b to a, and also b to c to b. Okay. Now b value must be a and c value must be b. Okay, this is the implication of it, and we have written the same thing, and this is the increment. Every time iteration must increment. Okay, this is the main logic where you need to apply your Fibonacci series. Let us check, right? If I give 10 terms, 1, 1, 2, 3, 5, 8, 13, 21. So you can check 1 plus 1, 2, 2 plus 1, 3, 3 plus 2, 5, 5 plus 3, 8, 8 plus 5, 13, 13 plus 8, 21, 21 plus 13, 34, 34 plus 21, 55. So you got your desired output. This is about Fibonacci series. Let us look into another kind of program, prime number program, to check whether a number is prime or not. So first you need to know what is prime number, right? What is prime? I hope everyone knows, but I am just briefly discussing the logic. Prime number must not have composite factors. Is it true? Yes. It must not have composite factors. One and itself. It must have what? It must have one and itself. So we can say that count using a variable called as count. Okay, I'm initially saying enter any number to check that number and take any variable count and an iterating variable I, scanning that n, nothing but for what number you want, and count to be 0 and I to be 1. So what I am doing here, while I less than or equal to n, nothing but 1 less than or equal to whatever number, let us take, right, 5 is prime or not. I want to know whether 5 is prime or not. 1 less than or equal to 5. Yes, it is true. So what I am doing is, for each iteration of this number, nothing but for iteration 1, nothing but for number 1 and 5, between these both, if the remainder is 0, then increment the count. Nothing but that means that the iterative variable is divisible by 5. This means that what? Or you can say it is the iterating variable is a factor of n. Factor of n. If it is a factor of n, count will get increased, nothing but count was 0 increased to 1. Okay, our agenda is what? Count must be 1 and itself, nothing but count must be 2. So whatever it may be, count must increment, and I also, after this if statement, I must also increment. So after doing for each iteration before that number, nothing but before 5, checking all numbers 1, 2, 3, 4 and 5 as well, because we have given equal to, checking for each and every number. If if more than 2 numbers are factor of this number n, that will be not a prime number. So that's why I'm saying if count is equal to 2, it is a prime number. What I said, if it is more than 2, whatever the numbers divisible by 5 you got, that is the count is more than 2, it is not a prime number. So I'm giving a case that if count is 2, it is a prime number. Else case I'm giving it is not a prime number. So let us do with the same example 5. It is a prime number. Okay. Suppose if I take any other case like 6. 1 is divisible by 6. Here you will get count as 1. For what? For 1, count will be 1. For 2, count will be again increment. Count again increments for 2 because 2 is divisible by 6. 1 is divisible by 6. Incrementing 1. 2 is divisible by 6. Incrementing 2. 3 is also divisible by 6. Count will become 3. 3 is also divisible by 6. So count will become 3. So count has become 3. It is not a prime number. That's it. From this part only you can tell. But again, the more iterations will be incremented. But you got here 3. So obviously it will be not a prime number. It is not a prime number. Okay. This is about checking of prime numbers. And let us look into a simple pattern. Okay. Nested loops, to show the usage of nested loops. I want to print this pattern: 5 1s, 5 2s, 5 3s and 5 4s, 5 5s. Okay, so what you need to do, nested loop in the sense you will have two things: outer loop and inner loop. I can say that using outer loop we can track the rows, and using inner loop we can track the columns. I'll tell you what is the meaning of it. To the simple part, using outer loop you can track the rows, and using inner loop you can track the columns. So here you can divide it as a rows into rows and columns, but let us make it simple, right? I'm taking two variables I and j. Because obviously if you are doing nested case, then you need two variables: outer loop one variable, inner loop one variable. So for outer loop I'm saying initially 1, and 1 must be less than or equal to 5. You have 5 numbers, right? So obviously less than or equal to 5 I'm telling, and incrementing after this inside part executes. Inside this loop, that is inside outer loop, I'm taking a variable j, and these are 5 values, and the number is also of 5 values. These are of 5 values, nothing but there are 5 rows as well as 5 columns. So you can tell that j less than or equal to 5. So the same condition you can write here, and for each of this iteration outer for loop, for each of this inner for loop must be printed. Nothing but for I equal to 1, 1 will be printed, and again what will be printed? Increment, I will be printed. Okay, so if this condition is true, 1 will be printed, and for 2 again 1 will be printed, again 1 will be printed. So 5 times till 5 ones will be printed. After that it is \n, nothing but new line. So after printing 5 ones, it comes into new line. Inside next new line, incremented, I was incremented to 2, So 2, 2, 2, 2, 2, 5 times. So similarly, you will be getting till where? Till 5, 5, 5, 5 times. Okay. This is the meaning of this pattern. Nested for loop pattern. You may be getting a different patterns of this. Okay, you can do that. This is about patterns, and these are the programs related to the control statements.